The modern day construction is totally depend on the concrete. In other words, concrete is the main pillar or the backbone of the projects. It has widely used in every projects. In today's video, we'll discuss about a special type of concrete, that is lightweight concrete. What is lightweight concrete? What is the brief history, why it is developed and how it is developed, and what type of different types of lightweight concrete and advantages and the disadvantages of the lightweight concrete. So stay tuned until the end to get the full information about the lightweight concretes. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's start about what is a lightweight concrete. From the name itself, it is showing that the lightweight, that means it is the lower density or the lower weight. The lightweight concrete is a specialized concrete mixed with a density typically lower than that of a traditional concrete. The concrete, we all know that 2200 to 2400 kg per cubic meters, but in the lightweight concrete, it is varies from 400 to 1800 or 1600 kg per cubic meter. Why it is required? It has the special advantages and it has the special uses of the lightweight concrete. And how we can maintain this lightweight concrete? It achieved by replacing some or all of the traditional aggregates with the lightweight aggregates. That means the aggregate which is taking the more load or the more weight, we are replacing it is whole or the some part, so that the total weight of the concrete will be less. So in the concrete offers a balance of reduced weight and impressive strength. So that the strength also we need to fulfill whenever we are replacing the traditional aggregates with the lightweight aggregate. So how it can be with the using of the lightweight aggregate, and other way also we can make, but mainly to replace the traditional aggregate with the lightweight aggregate. So these are the definition. That means the weight of density or the unit weight of the concrete less than the traditional one is that called the lightweight concrete. So little bit of the history, how it is evolved. So first things, the early experiments with lightweight aggregates in 1917 to 1920s. When in 1917, the expanded shale, clay, and slate institutes was founded in the United States, promoting the use of lightweight aggregates. So it was first founded in 1917, whenever the promoting the lightweight aggregate to use to making the lightweight concrete. Then what is hydride production in 1920, which is that in the 1920s, the production of lightweight expanded clay aggregates known as hydride began. Hydride became a popular choice for lightweight concrete due to its low density and insulating properties. So in the 1917 started, the first production of hydride is happening in 1920, and it is a very much widely used and very much become popular for the low density and the insulating properties. Then the development of autoclaved aerated blocks in 1923. In 1923, excuse me, the Swedish architect and inventor Axel Eriksson's patented autoclaved aerated concrete or AAC that widely used now. We are all using the AAC blocks, a type of lightweight concrete made by incorporating aluminum powder as an expanding agent. AAC quickly gained popularity in construction due to its excellent insulations and lightweight properties. Nowadays, we are all using the AAC blocks, but it is developed in 1923 by Swedish architect and inventor Axel Ericsson. The next is in 1930, introduction of lightweight aggregates in the United States. Lightweight aggregates, including expanded shale and clay, began to be used in the United States in the 1930s, particularly for the construction of lightweight concrete blocks. So AC block, then lightweight concrete. Then use of lightweight concrete in World War II in 1940. So the World War II has a significant impact on the invention of the lightweight concrete. During World War II, lightweight concrete was used for various military applications, including the construction of airstrips and bunkers. These highlighted the advantage of lightweight concrete in terms of reducing transportation cost and the rapid construction. So the Second World War, which has a devastating effect on the society and all over the world, but it has given the invention of the lightweight concrete itself for the transportation and the making faster construction. So in the during to World War II, it has gained the more popularity. Then research and advancement in 1950s and 1960s. In the 1950s and 1960s, extensive research and development efforts focused on improving the properties and structural applications of lightweight concrete. So after the World War II, when it becomes widely popular, then again the research and development has been founded and started to make it more applications for the structural properties of the lightweight concrete. Then introductions of expanded polystyrene, that is EPS, in 1960s. In the 1960s, the expanded polystyrene boards were introduced as lightweight aggregates, leading to the development of lightweight concrete with enhanced insulation properties. All we know that whenever the insulation blocks we need, we have expanded EPS board in between the lightweight concrete blocks, and it becomes widely used for the insulation blocks whenever the insulation is required in higher amount. So these insulation blocks is invented in 1960 whenever the EPS board has invented. Then the modern application and sustainability in the 21st century. How? In the 21st century, the lightweight concrete has found applications in various construction projects, including high-rise buildings, bridges, and the residential structures, where reduced structural weight and improved insulation are essential. So from 1970s now, excuse me, from the 1970s, now we are in the 21st century, and now it is widely used. Then ongoing research and innovation. Still today itself also ongoing research and development is going on that subject. So how it can be developed and it can be more advanced. Research into lightweight concrete continues to this day with a focus on enhancing the material strength, durability, and environmental sustainability. Innovations include the use of alternative lightweight aggregates and improved mixed design. So from the 1970s to the Second World War, EPS board invention, AC block invention, all are the steps by steps. And today we have find out we are in the stage that widely use this lightweight concrete and the light insulation blocks using this special type of aggregates and etc. Now the next, this is the brief history about how the lightweight blocks invented and how the research and development is still in the process. The next part is types of lightweight concrete. It becomes that whatever the agent or whatever the material we are using, depending on that, or what is the production procedure of the lightweight concrete, it becomes that type of concrete. That is aerated concrete, that is AAC. Foam concrete, what that means, whenever we are adding foaming agent, that it become foam concrete. And whenever we are using polystyrene board, that the polystyrene concrete, and then expanded glass aggregate concrete. So according to the material and according to the production procedure, there are different types of lightweight concrete also. The next is, what is the physical properties? The density. All we already discussed that the lower density as compared to the traditional one. The dense lightweight concrete typically ranges from 400 to 2000 kg per cubic meter, but still research and development is in the air so that it can be modified and it can be find out more beneficial. Compression strength, it can vary widely but often falls between 17 and 41 MPa. It is the main drawback that we cannot achieve more than that, but research and development still is in the process so that using the lightweight aggregates we can achieve the more strength. And then thermal conductivity with a range of 0.15 to 0.75 watt per meter kilojoule, it offers a good thermal insulation. It always using as a thermal insulation block. So AC block is widely used for the thermal insulation. And the sound insulation, lightweight concrete exhibit excellent sound insulation properties. So whenever we need a better sound insulation, that times the AC block is #1 choice. And the fire resistance, it has good fire resistance, making it ideal for the fire rated structure. So the thermal conductivity, sound insulation, and the fire resistance all has the wide range of varies, and it is a good thermal properties of that. So that's why these that's why this lightweight concrete is widely used now, and still for that betterment for the strength and durability, the research and development is there. Maybe in future we'll find out more durable and more strength concrete using the lightweight aggregates. Then what is the chemical composition of the lightweight aggregate? It includes lightweight aggregates like expanded clay, shale, or slate. Portland cement is the primary binder, and then air entraining agents. These are often added to improve workability and freeze thaw resistance. Air is very much important whenever the freeze thaw cycle is happening. So if the freeze thaw cycle is happening inside the concrete, it will break the concrete, cracks will appear. To resist that freeze to cycle, the air we are entering inside the concrete. So in the lightweight concrete also we are entering air so that it can resist the freeze thaw cycle. And the chemical admixture and the foaming agent, whatever as per the production procedure is required. So these are become the chemical compositions of the lightweight concrete. Then what is the advantages of lightweight concrete? Then we already discussed. First thing, the reduced weight. Why then? What is the reduced weight? It has the dead load will be the less in the structure, so there will be a less load on the structure. Then improved insulation. The insulation is the huge properties, and it can be used widely for the thermal insulation. Then sound insulation. Then lower structural load. Then fire resistance and the sustainability. So it has wide range of advantages to use the lightweight concrete. So it is widely used in itself in the constructions, and again the modification and the enhancement also is there. So we will find out more durable and more strength concrete in the in the future. So these are the advantage of lightweight concrete, but there is some disadvantage also. Let's see what is the disadvantage. That's a lower strength. That means we are not achieving that much of strength what is required in the high-rise structure and everything. So it is not completely replace the traditional concrete. Still it is using for the other part, that is the thermal insulation, sound insulation, and lower strength categories. And the special mix design is required, so it needs more quality control. And then limited load bearing capacity, as we discussed, that the lower strength or lower load bearing capacity, hydration rate, durability, and the quality control. These are the disadvantage of lightweight concrete. But still, as we see, the from 1917 to still now, the research and development is there. So we hope in the near future we'll get the more durable, more strength, and more rapid concrete, so that it can replace the traditional concrete, so that our structure have the minimum load. So these things are about the lightweight concrete, and I hope you find it useful. And if you want to know about anything about the lightweight concrete, please let me know in the comment box. I will come with more content like this. And if you're new in my channel, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notifications. And I'm waiting for your valuable comment, so that from your comment everybody can be benefited. Thank you once again for watching.